Looks like we have an actual new one here. There's been a run of previously done ones for me. Anyways, minimum time to make rope colorful. Alice has N balloons arranged on a rope. Okay. You're given a zero index string colors where colors of I is the color of the ith balloon. Alice wants the rope to be colorful. She does not want to have two consecutive balloons be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You're given a zero index integer array, needed time, where needed time I is the time in seconds that Bob needs to remove the ith balloon from the rope. Return the minimum time Bob needs to make the rope colorful. This is medium. What? Okay. There's the weight to the time. I mean, yeah, okay. So I mean, for any, so basically, if you have a streak of colors of similar colors, like a streak of blues, then you would need to keep the blue that has the highest time of that streak. So if there was like all 5 blues here, then you would remove the blues that are the lowest time and you keep the highest time blue. Okay. That should be min, so it should be O of n, I think, for this overall algorithm. Yeah, so you keep the you keep the blue that has the highest time cost to remove here. You keep the blue that has the highest time cost here. And you remove the blues. You would sum up all the blues that have the lowest cost. Okay. Okay, so let's go ahead and answer equals 0. So I just need to consider streaks. Streaks of the same color, the sum of the items in that streak, and the highest cost of the items in that streak. So for let's see, index or n is equal to length of colors, which is the same as the length of the needed time, I believe. N is the same for both, right? Okay. Okay, so I think maybe I'll have a current streak. I'll have a streak that is cost, and I'll have a streak high, the highest amount. And I think even I can treat it as streaks of 1, where the sum of the streak of one color would be that one thing, and then the highest cost would be one thing, and the answer would be incremented by the total cost minus that high cost, which is going to be 0. So the time needed to kind of make correct a one streak color is 0. So I think here it should be for every index in range n, color is colors at index, and if this matches the previous color, what is color? Is it ABC? Colors, so I need to compare it to the previous one. I think I'll make a dummy color at the end, maybe. Actually, can I append to a string? Can you append to a string? I don't think so. Strings are immutable yet. I guess I'll okay, yeah. I guess I'll just go from 1 to n. Initial streak cost should be the initial needed time. Needed time is 0. The highest is needed time is 0 as well. And I'll just compare colors here. So for if the current color, which is colors at index, is equal to the previous colors at index minus 1, then this is continuing the streak. So streak cost would increment by whatever the needed time for this color, what this index is. And the streak high would be if the needed time at this index is greater than the previous needed time, greater than the high. Streak high is going to be set to this, and else if it's not, then this is a new streak. So it should be answer incremented by the total cost of the streak previously and the high of the previous streak. And I need to reset it after that. Reset it, streak cost should be this current needed time of this index. And I guess that's the same thing as the streak high. And then I think I don't think it captures the last one. So I think I need to do one more, answer plus equals streak cost minus streak high. Okay, so this is just blindly running it and hoping it works. Whoops, this should be index. That's misspelled and also tabbed incorrectly. Well, no, actually. This indentation seems slightly off to me. Oh, whatever. Okay, works. Okay. Let's see if I can improve this. I think this should be similar to this line here. Streak cost equals streak high equals needed time is 0. And I've seen cases where it actually goes faster if I use a for each loop rather than a for loop that uses indices. So I'm wondering if I can actually do a for each loop here. I don't think so because I think I need indices to work with both the colors and the need time. So yeah, I need indices there. Colors. Range from 1 to n. Increment the streak cost. Only set to be higher if necessary. At the end of the streak, Oh yeah. So I think that's it. Summary. So basically, if considering the string or the layout of balloons as composed of streaks of colors. So for, let's say it's like blue, blue, white, white, red, red, red. That would be like 2 blues, 2 whites, and then 2 reds and 3 reds as streaks. For each streak, and this includes includes singleton. The time needed to kind of make colorful equals the time needed to make the streak into a single balloon, which is going to equal the total time of all the balloons minus the time for the longest balloon or the highest balloon. Time for the highest balloon. As you would want to avoid spending time removing that balloon over, oh, I'm misspelling balloons, oh jeez. Wow, I'm misspelling balloons so often. Over other balloons. Moving that balloon over other balloons. So, use for loop, which goes over indices, track the current streak of balloons with variables for total cost of balloons and highest individual balloon cost. Oh my god. If streak is done, i.e. current balloon color differs from previous balloon color, then increase the answer value by total minus high time cost of last streak, and reset to the new streak. So yeah, initial streak is just the first balloon for every later index balloon. If it matches, then it's a current streak, so extend it, increase the streak cost, update the maximum. If it's a new streak, which is the colors are different, then increase the answer appropriately and reset to the new streak, which is the current balloon. Okay, time complexity, this can be O of n, where n is the number of balloons. Each iteration of the loop does constant work. And space complexity should be O of 1, as no additional space besides the variable counters are needed.